Hello, this is Miss Moore, and today during chemistry we're going to discuss molarity and pH. Today's essential question: how is molarity related to hydroxide and hydronium concentrations? For today's lecture, you are going to need your calculators handy. We'll start with a quick overview of solutions. So a solution is a liquid mixture. It's made up of two things. It's made up of a solvent and a solute. Okay. The solvent is the primary component. It's normally a liquid because a solution is a liquid mixture. And the solute is the thing dissolved in the solvent. Okay, so for example, if I were to make sugar water, where I add sugar to water, stir it up for some reason, water would be the solvent, and sugar is being dissolved in the water, so it is known as the solute. Concentration. The concentration of a solution is a measure of the amount of solute that is dissolved in a given quantity of solvent. Okay, so we could talk about concentration qualitatively by using terms like dilute and concentrated. So a dilute solution is one that contains only a low concentration of solute. So if I had a cup of water and only put a little bit of sugar in it, that would be a dilute solution of sugar water. A concentrated solution contains a high concentration of solute. All right, so if I took that same cup of water, put a whole bunch of sugar in it, I would have a concentrated solution. Okay, so we just talked about how to qualitatively describe a concentration using descriptive words like dilute and concentrated. But that doesn't really tell you how much sugar is in the water. A dilute solution means not so much, and a concentrated solution means a lot. But that's, relative. All right, so another way to express concentration is using something called molarity. Molarity expresses concentration quantitatively with numbers. So instead of saying it's a dilute solution, I could say it's a 0.01 molar. That gives people an idea, or exactly actually, how much sugar is in that water. Okay, so the definition of molarity is it's the number of moles of a solute dissolved per liter of solution. Okay, and so basically, molarity is a numerical value showing how much stuff, how much solute is dissolved in the liquid. Okay, so it's not too big of a deal. Here comes the math part. So to determine molarity, we're going to use the equality. Molarity, also capital M, equals moles of solute over liters of solution. Okay, important. You are more than welcome to write that on your unit conversion table. The units for molarity are either capital M or mole per liter. They mean the same thing. Capital M means mole per liter. Mole per liter means capital M. Okay. When you're writing an answer, you can use either capital M or mole per liter. This is really important. But when solving a problem, use mole per liter. So I guess a good way to think about this is that the capital M is for answers, and mole per liter is for solving problems. Okay? Really important. It'll make the problems much more difficult if you forget this. Okay? When solving problems, use mole per liter. Okay, now we just need to try this. Okay, so a practice problem. A chemist wants to make 7.5 liters of a 6 molar solution of sodium hydroxide, NaOH. How many moles of NaOH will the chemist need to make this solution? All right, remember, we're using the formula molarity equals mole over liter. Okay, and the way I do this is I make a list of all the possible variables. We have molarity, we have moles, and we have liters. And then I read through the story. A chemist wants to make 7.5 liters, well, that's liters, of a 6 molar solution. That goes with the capital M, 6M. But remember, we're solving a problem right now, so we're going to do this as 6 mole over liters. How many moles? That's our X, right? There you go. Now we just take that information and plug it into our formula. So we're going to have capital M, which is 6 mole per liter, equals mole over liter, X over 7.50 liter. Okay. Now, to solve a problem where you have two fractions with an equal sign in between is that we cross multiply, right? So we're going to multiply those guys. So we'll have 6 mole times 7.50 liters equals, and we're going to multiply these guys, X liters. All right, when I multiply, please do this with me, make sure I did it right. I got 45 mole liters equals X liters. Now we need to solve for X, and so what we'll do is divide both sides by liters, and we end up with 45 moles. X equals 45 moles. Last step is to check sig figs. So if we go back to our list here, we have 1 sig fig and 3 sig figs. So we're going to have 1 sig fig, which means we're only going to keep the 4. So 5 or bigger, so we're going to round up to 5. And then because we're dropping a number, the 5, before a decimal, we need to add a placeholder. So our final answer is going to be 50 moles. Okay. All right, let's now talk about how to determine the molarity of an acid. So to determine the molarity of an acid from the concentration of H plus ions, or remember, that could also mean H plus is the same as talking about H3O1 plus, or to determine the concentration of the H plus ions from the molarity of an acid, you're going to use this equation. The subscript of the acid times the concentration of the acid equals the concentration of H plus or concentration of H3O. To determine the molarity of an areneous base, one that ends with OH, you can do that from the concentration of OH ions, or you can do it from the molarity of the base. You are going to use a very similar equation, except for its subscript of OH times the concentration of the base equals the concentration of OH. Okay, here's a list of all of the equations we have so far for calculating pH. And for the most part, the things on the left are the things you're trying to find, the unknown. So we could be finding H3O or OH, pH, POH, H3O, OH. And on the right side is the stuff you already know, which could be, what you know. Okay. So now that you have that, let's try to do a practice problem. So we're going to do the problem, determine the pH, POH, concentration of H3O, concentration of OH of a 3 molar solution of H2SO4. All right, the first thing we should do is draw out our little data table. And now we need to figure out what the heck to do. So what they gave us is 3 molar H2SO4. So let's see what we can do with that. Well, 3 molar is a concentration and H2SO4 is an acid, so I guess we can use that formula right there. So we're going to have the subscript of H times the concentration of H. Times the concentration of the acid equals the H3O or H1 plus concentration. All right, so our subscript for H is right here. It's a 2. Our concentration is 3 molar, which means our H3O concentration is going to be 6 molar. So our H3O concentration is 6 molar. So now that we know concentration of H3O, let's see what we could figure out. So what we know is concentration of H3O, so we can figure out the pH, or we could also use this to figure out the OH. I'm going to pick doing that one, although it doesn't really matter. Okay, so we're going to use the equation, concentration of H3O times the concentration of OH equals 1 times 10 to the negative 14th. We know we have 6 molar. We don't actually need that unit. So we know we have 6 molar. We don't know the concentration of OH equals 1 times 10 to the negative 14th. We'll divide both sides by 6. And when I put that in my calculator, I got 1.6666666 on and on times 10 to the negative. Got the best going on there. Times 10 to the negative 15th. But we only have 1 sig fig, so our concentration of OH will be 2 times 10 to the negative 15th. All right, so now we know the concentration of H3O and the concentration of OH, and with those two pieces of information, we can figure out, I did that one wrong, pH and pOH. So for pH, we'll have pH equals negative log concentration of H3O, which gives us negative 0.778 and so forth. With only 1 sig fig, we'll have negative 0.8. And pOH is negative log of the concentration of OH, which is 2 times 10 to the negative 15th. And when we put that in, we get 14.698 and so forth. With only 1 sig fig, we'll end up with a pOH of 10. And our last bit of information is this thing an acid, a base, or neutral? And we will use the pH to determine that, which is less than 7. So this guy is an acid. All right, let's try one more quick problem. If we have a solution of H3PO4 and it has an hydronium ion concentration of 2 times 10 to the negative 2, what is the concentration of H3PO4, which is an acid? Well, let's go back and look at our formulas and see what we can use. Keeping in mind we have the H3O concentration. And let's see, we want to find out the concentration of the acid. We know the H3O concentration, so why don't we use that formula right there? So we're going to use the formula, the subscript of the H times the concentration of the acid equals the H3O concentration. All right, so we know the subscript of the H is a 3. We don't know the concentration of the acid, that's our question. And we know the H3O concentration is 2 times 10 to the negative 2. So now, to solve for the acid concentration, we will divide 3 on both sides, giving us an acid concentration of 6.66666 and so forth times 10 to the negative 3. We only have one sig fig, so our final answer will be the concentration of H3PO4 is 7 times 10 to the negative 3. All right, folks, that's it for today. Have a good one.